One of the most important things you're going to learn about in Physics 1 is the horizontal projectile. A projectile is an object that has only one force working on it, gravity. There are different types of projectiles. For example, an object thrown from rest straight down, an object thrown straight up, or what we'll be focusing on, horizontal projectiles, such as an object being rolled off a table, or an object being kicked up at an angle to the horizontal. Regardless of the shape of the projectile, they all have one very important thing in common, that gravity is the only force working on that object. And because of this, their free body diagram will look like this, no matter where they are in their projectile motion. Now, the reason horizontal projectiles can get so confusing is because they have motion in both the horizontal and vertical directions. And this is different from the kinematics problems we're used to doing. But if you're able to differentiate between the forces, acceleration, and velocity in each direction, you'll be able to tackle any kinematics problem the AP throws at you. Some important things to remember are the forces. In horizontal motion, the projectile has no forces working on it. And because of this, its velocity is going to be constant throughout the entire projectile. Redundantly, it has no acceleration. On the other hand, vertical motion has the force of gravity working in the downward direction. As a result, it has an acceleration of g, or 9.8 meters per second squared. As a result, the vertical motion is going to have a changing velocity over the projectile.
If you still don't think that horizontal projectiles are important, just note that the following question was on the 2015 Physics 1 exam. There were two balls. One was dropped, and simultaneously another was launched from a horizontal projectile. The question was, which ball hits the ground first? Now, you may think that one of these balls hits the ground before the other, but the answer is they hit the ground at the same time. Vertical and horizontal velocities are independent of each other. In this equation, as Haarika already stated, since there is no horizontal acceleration, delta x equals voxt plus 1/2 times 0 t squared. Now, since we already noted that the velocities are constant throughout the entire projectile, delta x equals vt. For the vertical component, acceleration is gravity, or 9.8. And initial vertical velocity is always 0. This is really important for you to get horizontal projectile questions right. So the final formula is delta y equals v o y, which is actually 0, t, plus 1/2 a t squared, or delta y equals 1/2 a t squared. Using these two formulas, you could plug in all the components you're given and find the answer to the horizontal projectile question. You could also use t here and plug it in here to find the horizontal distance, the vertical distance, or the horizontal velocity.